Today we're going to prove this identity. X to the n minus y to the n is equal to x minus y times this expansion. Now this is the generalization of this property that we've been discussing, which is x squared minus y squared is equal to x minus y, x plus y. And if you can see, this is the general expansion. It becomes clear when we combine this with this other previous video we did. If you remember, x minus y, and then this was x squared plus xy plus y squared. And if you notice, if you follow this pattern, this is how we get to this expansion right here. Okay? So the proof is going to be very similar to how we proved these previous two. We're going to take the side with the most information and then compute it to get to this side that we need. Now, first we need to assume that x and y are real numbers so that the following properties of real numbers hold. So these are real numbers. Then we take this part of the expansion and we work with this until we get to this. So then x minus y times x to the n minus 1 plus x to the n minus 2 all the way down to x y to the n minus 2 plus y to the n minus 1. This is going to equal, since these are real numbers, the property of distribution holds. So this will be x times this expansion. And then plus, and it'll make sense why I'm, or minus, sorry. It'll make sense why I'm doing this right now. Minus y to the same expansion. Now, when I distribute this, I can distribute again. So then this is going to equal x times the first term plus x times the second term all the way down to the last two terms. So all I've done is just distribute this x to all these terms. And then the same thing goes for the y. So this is y times the first term. And then this is y times the second term. Minus all the way down to the last two terms. So now we need to recall some properties of exponents. So when I multiply these two numbers, since they have the same base, you add the exponents. So now this will be x to the, instead of n minus 1, this will be n. And then this will be plus, instead of n minus 2, this will be x to the n minus 1. And then this applies all the way to the end. So this will be x squared And then finally, this is just x. And then this will be underneath minus y x to the n minus 1 minus y squared x to the n minus 2. Then all the way down to y to the n minus 1 x, and then minus y to the n. Now notice this. Because these are real numbers, we can use the property of commutativity to see that these two are the same number. Right? Do you see how these are two of the same numbers? So what we can see that these are eventually just going to cancel out. And the same thing is true with this number and this number, right? And if you notice, you can kind of see that this is going to cancel with all these terms here. So all these terms are going to cancel out, kind of like a sandwich, until we just have these outer terms. So what are the outer terms? The outer terms are x to the n minus y to the n. And then that is the proof.